to HPC Now, another episode brought to you by Dell Technologies. So today we have an interesting lineup of three separate topics from our subject matter experts. And one of them is going to be about bringing business value to enterprise computing. Very interesting, using high performance computing. So bringing business value to computing using HPC. This is going to be a very interesting topic and kind of insightful. The second one we have is the cloudy cloud with HPC. Like, what is cloud with HPC? And we kind of demystify a little bit of that. And then the third one is finding Goldilocks of HPC. That is finding the right way to put together HPC. And we have some guidance on that. And I think you'll find it pretty insightful. So why don't we get going? And I'm going to turn it over to my foreign correspondent, Ashley Lanham. Ashley, take it away.
Well, Tony, thanks so much for having us today, and I'm really excited about our speakers, always experts in their own right, with three very different topics today. So I, for one, am really interested about this Goldilocks thing. We'll get to that later. Right now, I heard we're going to demystify HPC for the enterprise. Elliott, lay it on us, my friend.
Thanks, Ashley. I appreciate that. I'm going to share some information for you. Great. So today we're going to talk about delivering business value with high performance computing. And we're focusing, again, entirely on high performance computing. I'm sure you have at least a general understanding of high performance computing, but to recap very briefly, I often say that high performance computing is the opposite of server virtualization, where in server virtualization, that's the process of encapsulating server instances logically and then running multiple of these logical or virtualized server instances on a server to increase utilization and data center efficiency. Whereas in high performance computing, it's the process of spreading compute intensive workload across multiple physical servers by aggregating the servers logically into one virtual supercomputer capability to harness the aggregated computing horsepower within the group. So that's the difference in server virtualization. As it shows, you're virtually taking one server and making it behave like many servers, whereas in high performance computing, you're taking many servers and making them look and behave like one server, one virtual supercomputer. And why would we do this? Well, as one of my colleagues likes to say, because the world is painful. If we didn't have high performance computing, it would definitely be difficult to design cars and airplanes and phones, drugs, as we've seen in the pandemic, as quickly as we expect. In order to design a car and crash it to prove its capabilities in a real world scenario, we would need many cars to test even a fraction of the scenarios that we might encounter in the real world. So crash testing is one of the traditional workloads that we find in high performance computing. And there are many other traditional workloads, such as analysis of all types of fluid flow, finite element analysis, molecular dynamics, weather forecasting, and analysis of seismic data. These applications typically involve harnessing many cores to run a complex parallel algorithm. Beyond those applications, there are many scientific disciplines that are data-driven. And they've also developed the ability to scale and achieve great degrees of acceleration by running on high-performance computing clusters through the use of embarrassingly parallel methods. And on the far left, we have artificial intelligence, which is a broad field focused on, quote unquote, teaching computers to perform tasks in ways that imitates human intelligence.
Hey, Elliott?
Yes.
Hey, I've got a question. I hear about the convergence of AI and HPC. Have you heard? Can you talk a little bit about that? Are you planning to?
Absolutely, absolutely. We're thank you for asking that question. We're jumping into that right now. Basically, what we're seeing is that customers are adopting high performance computing techniques to run machine learning and artificial intelligence workloads. Basically, what we find is that it's all about the data. That customers have more and more data in their environments, whether it's server management data streamed from iDRAC, for example, or the rapidly growing volumes of data from all sorts of laboratory and clinical instruments, data from consumer devices such as cars, smart speakers, thermostats, what have you, Twitter feeds. There's more and more data that you, our customers, want to access. In fact, what we have understand that it's been the data has shown that that the rate of growth is huge. It's as much as 27% in terms of the annual data growth rate, which if you're managing storage may frighten you, but if you think about the world in which we live, the rate of data growth is indeed huge. And while our customers are continuing to use high performance computing and gaining more experience with data analytics and artificial intelligence methods, they're finding that these workloads are indeed converging, as Tony asked. First off, scientists are finding that some research pipelines run faster by combining artificial intelligence and data analytics methods with traditional HPC workloads. So that is, artificial and data analytics are being used to augment and accelerate traditional high performance computing workloads. But on the other hand, of course, data scientists and researchers are developing new processes for solving their problems at massive scale. And that requires compute resources like those found in high performance computing systems. So artificial intelligence and data analytics workloads can benefit from high performance computing infrastructure that scales up to deliver massive performance improvements. The convergence of these workloads is causing customers to look for a unified architecture that will support all of these different types of workloads. The
Elliott,
convergence.
could I ask a question?
Yes,
sir?
Ashley, sure, please.
You had just mentioned that we're looking for ways to, I'm sorry, what did you had just mentioned how we're going to solve the problem. And I'm sorry, I forgot the term that you used. But can you give us a little more insight?
Data analytics,
how do you
artificial
see
intelligence.
converging that? Yeah, how do you see that occurring?
Right, so we see that customers are utilizing high performance computing methods, including scheduling with traditional high performance computing schedulers, and as well as developing a capability to provide dynamic resource allocation between traditional high performance computing schedulers and other types of workload managers such as Kubernetes, and being able to actually drive Kubernetes workflows through these same architectures and providing flexible resource allocation to run all of these different types of workloads in the same environment. What we're seeing is that this market is growing tremendously. Regardless of how you look at it, the high performance computing market is growing, and is huge and growing quickly. The amount of data, as we've discussed, for example, with medical data is huge and growing rapidly. The amount of data for that we are processing and expect to with regard to weather forecasting is growing quickly. All sorts of data is growing very rapidly, so it's really important to have this capability of leveraging these scale-out infrastructures for data analytics and artificial intelligence, as well as traditional HPC workloads.
So Elliott, what you're saying is in the enterprise, the problems are getting more complex and difficult to solve, and the data is getting larger and larger. And using traditional methods of enterprise computing can't get the results fast enough. Is that kind of what's happening here?
Yes, that's a great way of summarizing it, Tony. Yes, absolutely. And we're seeing.
Elliott, I have another question. Well, I'm sorry.
Yes, Ashley, no, sure, please.
I'm also curious is, you see the expansion of analytics and AI usage across the enterprise. Do you think it's fair to assume, and I swear I'm not leading into your next slide on purpose. It just looks like it did. It seems like HPC will be more broadly used than we've seen in years past. Do you think that that's reasonable?
Absolutely. Absolutely. We see high performance computing methods being leveraged across many industry verticals, from traditional usages in research, but as well as in many other situations, such as in life sciences, manufacturing, oil and gas, financial services, media and entertainment, as well as in other industries as well. Really across the board, we're seeing use cases for high performance computing as well as for artificial intelligence methods. And really the ability to utilize scale out infrastructure such as we find in high performance computing environments is necessary to be able to run those workloads efficiently and be able to return results in the manner that we expect to drive business value.
So Elliott, let's say an enterprise customer, someone in a company like a Fortune 1000 company, is getting frustrated because the data's gotten too big, the problem's too complex, and the time it takes to get the results is just too slow using conventional methods. How would they get in touch? Who would they call to maybe do an assessment of whether or not HPC would be helpful?
So our approach at Dell is to provide a comprehensive practice in high performance computing and artificial intelligence. We have teams that have been organized to support this entire practice from top to bottom. We develop solutions for high performance computing and artificial intelligence in our high performance computing and artificial intelligence innovation lab in the Austin area. We also have a number of other facilities where we perform this testing. We build these solutions and test them at scale, and then develop documentation around those solutions, and have a team of experts in the field to help our customers to understand how they can utilize these solutions for their benefit and to drive their business perforance.
Ashley, what do you got there?
Gentlemen, I have teleported to the Dell AI Innovation Lab in Austin, Texas. Here I am, local.
She's just amazing, isn't she?
Ashley just teleported into our lab.
I'm just flying all over. But Elliott, one of the things that I think I heard, and I just want to validate with you, is it true that customers can test their code on systems before those investments to make sure things are going to be optimized?
Absolutely. Absolutely. That's
awesome.
One of the capabilities that we provide to our customers to lower their risk and increase the speed at which they can adopt this type of technology, this type of solution to deliver business value. Absolutely.
That's great. So Elliott, that's pretty cool. So I guess if a customer wants to find out more about HPC from Dell, they call their Dell salesperson. Is that what they do?
Absolutely.
Yeah.
Absolutely.
Okay. Well, thank you very much, Elliott. Ashley, anything else?
I mean, this is pretty awesome. I would love to hear, maybe on a future edition, we could dive into more of the cool use cases, Elliott, that maybe you're seeing come out in the market, because I've heard some just amazing things are going on, from personalized medicine to how we can make cooler movies and CGI, right? So can't wait to hear more on that. Thank you so much for joining us today.
Yeah, thanks, Elliott.
You're welcome.
Tony, I think we're up for our next speaker. Is that correct?
I think we are. Who do we have here?
Well, my friend, today we've invited Guy Adams to talk about Cloudy Cloud. Guy, explain your Cloudy Cloud terminology for us today.
All right, Guy, take it away.
I want to own the fact that I don't like the word cloud. It's hard to understand when someone says to us, and especially in HPC, hey, I've got to go to the cloud. What does that really mean? It just seems like part of our job is to really understand what is the customer's goals? Why do they want to get out of the cloud? Because, I mean, think about it, if you ask 5 people, what is a cloud? You know, you're going to get maybe a 5-year-old kid say, well, you know, it's the floaty things in the sky, you know, and they're going to say they come in different shapes and sizes and you get wet with them. And, you know, those are those kind of clouds. And then other people are thinking, well, it's a methodology to deploy services for IT. And somebody else thinks it's Amazon. And other people think, you know, who knows what they think. And so it's really challenging. So the exciting part for us today is we get just a chance to just pull the string a little bit and see if we can unwind it a little bit in our area and talk about that. Because there's a few key questions and we'll find out, you know, what does someone mean when they reference that cloud? Are they talking about usually a public cloud provider, say Amazon or Google or someone like that, where they can just easily log in and get a service or buy some hardware, or, I mean, rent some hardware, so to speak, you know, as long as you got a credit card. You know, maybe it's easier to use for them, or they don't have to pay for their capital outlay. So we really have to say, you know, really, do you want it they want it on premises? Do they not want it on premises? Do they want to have nothing to do with taking care of their hardware? Do they just absolutely have no facilities or have no staff that they want to deal with? You know, there's these questions that we have to ask. And as we go through that, we sort out really those main points. And we're going to cover those points here in just a second, because that's what really helps us understand. Because honestly, if you just go Google looking up the cloud in the dictionary, it's got a pretty generic meaning. It's like blah, blah, blah. Something like it's a practice of using network computers to do work. Well, that's not very helpful for your average person trying to understand cloud, guys. So anyway, let's demystify this real quick. And it's exciting because today we have so many more options. At HPC, the way Elliott was explaining, it used to be that the only option you had was you had to make it a capital investment and you put it on your premises, or you went to a co-location facility and you built an HPC solution, whether it be full of GPUs or regular CPUs. It had the storage, lots of networking involved, and it was tailor fit basically for your workload. Now we have options for, you know, we can do it on your premises, but you don't have to manage it. You know, we have a group that will manage it for you. So you can have all of the system administration and patching and all that stuff done for you in application building. Or, you know, you can burst out into the cloud. So maybe you have jobs and you want to just run some extra workload, throw them out there. Well, that's great. So, you know, maybe you look to use cloud for that. Maybe you have a cloud mandate. We hear that a lot. Oh, well, I have a cloud mandate. And so really, we have to drill down to the cloud mandate. Does that mean you have to run on a public cloud? Does that mean you have a Google, you know, account special setup that you have to run on? Or does it mean they want you to begin to move to containers and run containerized workloads somewhere? So at Dell, what we do is just exactly what Elliott said. As a team, we come in and we help you evaluate what it is that you're really looking for. And really, it boils down to just a few buckets when you really drill it down. It's, you know, really, I don't want the hassle of running a data center, and I'm willing to pay some extra money to just not have to run a data center. Another one is I need to burst or scale really quickly. I've got a program coming in. I got 6 months. I'm going to need, you know, 10,000 cores, and I don't want to buy 10,000 cores for only 6 months. I just would rather use them and move on. Third bucket would be, you know, I have some data center space, but I just don't want the hassle. It's so hard to hire HPC people these days. And I want to use my OpEx. I just want to have an OpEx payment method, and that's another bucket. And then the fourth bucket is, you know, we really want to just use a public cloud. We love using Amazon or the services, or we love using Google, or, you know, Dell's working on ours we're going to be ready with right away. You know, we're going to have some solutions out there that you can pick any of those buckets, and they get solved differently. And that's why you need the Dell side folks. We can solve this and help you work your cloudy cloud into a bucket, and then we can solve your problem more specifically for your need, if that makes sense. I'm just trying to take the clouds and part them a little, I guess.
Guys,
yeah.
So what about the journey customers take with the cloud? Can you give some examples of that? So
yeah, I really can. You bet. I can think of an example right now where we had a customer doing some medical research on drug discovery. And because they were a starting up company, they didn't have the immediate capital to buy the kind of system that they needed, but they had some on-hand OpEx budget. So they immediately went and began to prototype in the cloud. And they got their prototyping going and they got it up, and then they realized, okay, now we're big enough, and some investors bought in, and they got a lot of funding. And part of that funding was to build a large scale GPU enabled computer that they could utilize. So they took the step into the cloud for what it was good at, got them prototyped and scaled. Then they moved it back on premises to save money, and they set up a solution. Then there's the opposite case, right? The people that have been doing HPC for a long time, but then all of a sudden they've got a project that just came in because they won a short-term contract or something, and they just need some extra cycles, right? And it's going to take too long to figure out how to add them into their system and get it going, but they could easily go out, give a credit card, and add more nodes to their system and burst out onto that. So those are the most common right now, Tony. We do see some people that are really seeking to, carte blanche leave and go into the cloud, and that's a complicated question in HPC.
It's
really
not that
complicated.
simple. It's not that simple.
No, it's not that simple. And it's not that simple because typically the cloud looks at running workloads in a container, which, is like a little bundled OS and all of the files and libraries around the code. And it runs. And we just in HPC traditionally have never built them like that. So it can be done. It is being done more frequently, but it's not as simple as someone says, well, just go run it in the cloud. And as an HPC provider, it's a daunting question. It sounds easy to ask. It's really hard to deploy. So we at Dell are here to help you. That's right. We come alongside you. We figure it out. We say, okay, if you are containerizing those codes, those are good candidates to be run in the cloud, and we analyze it with you, and that's what our teams do. So I really appreciate you guys today taking some time to sit down. It is a cloudy subject, and I still really don't like the word, but it is simple as finding out what bucket is that they're talking about. Do they really want to get out of, paying capital every 3 or 5 years and upgrading? They just want to have, an easier way, or do they want
right?
public
And
cloud?
Dell has a lot of flexibility on the types of financing options, right?
Yes, they do. We have every option you can imagine out there, and we'll tailor make it for you too, which is really exciting. Sit right down with your CFO and work out what works best for your company. Yep. Thanks.
I heard of this thing called, let's see, what was it called? I think it was Apex Custom is the word that I heard, and I believe that was based on Dell's offering a Flex on Demand. Do you mind if I just run my understanding by you, make sure it makes sense? I think I understand it, but I want to make sure.
Yeah, I'm a little bit with you, Ashley, and let's, as Dell develops our offering, we're trying to make a flexible offering that customers can use in the cloud. And the term we're using is Apex. Apex is Dell's cloud offering. It's being expanded right now to include HPC type workloads, but it's being done thoughtfully. And what I mean by that is, instead of just grabbing any old random virtual machine and, just putting your workload out there, we're doing more mapping where we're trying to decide, okay, that really does need more dedicated resources of that virtual machine, which actually maps to the hardware, to the actual physical machine. And a lot of thinking is going into what's going on behind Dell's cloud, because it's hard to predict how long something will run when you're getting a virtual machine and getting a slice of a real machine. It's really a lot easier when you get the whole machine and yours. So in Apex, we lay out a whole program, and a lot of that has to do with what Tony said, the financing model. Where does the hardware sit? Does a cloud have to be off-prem? I mean, can it be partly on your data center because your data's locale is there, but still behave like a cloud? Yes, it can. And that's where we're going with Dell, is to provide the most seamless way that fits into your world and operates in a cloud model.
Yeah, I heard that Apex, one of the Apex custom options that it's typically applied to HPC involves what was called Flex on Demand, where Dell is actually installing more hardware than what you pay for. So you have that burst capability on-prem. I found that very interesting.
Yeah, it's exciting. And someone might ask, why would you want to do that, Ashley? Why not just run out there? And the answer is, a lot of times you have a massive, waiting on lead time and data, and data exactly, and data location, right? I mean, we all know, copying data around costs ingress and egress fees. And so if your data is local and you can run that and still have the beauty of a cloud, then it's a win-win for everybody. Yeah. So we're excited about what we're coming up with to deploy at Dell. And I just hope I've given everybody some food for thought. So thank you for your time.
So Guy, that was great.
Yeah, that's awesome.
That was really a fantastic explanation. It kind of, I can see the clouds parting already, and it's becoming very clear. So Ashley, what do we got now?
Well, since we don't have copyright licensing for playing the song that I'm sure everybody has in their minds when you say, I can see clearly now the rain's gone, because that's not copyright infringement. I'm going to pivot now to our last and awesome speaker, David Griggs, always bringing some great information for us. And I believe today we're going to do some throwback to old Goldilocks and the Three Bears, finding that right zone for HPC systems. So with that, David, I'll hand it over to you.
So I was going to talk today about the Goldilocks zone, sweet spots for HPC. So oftentimes when we're designing a system for a customer, we have to balance many different aspects of the system design to help get them into what I call the Goldilocks zone. So we're kind of trading off one factor for another, looking at more racks, less racks, more density, less density, more cores, less cores, more memory, less memory, all these different factors that we can use to tailor a design. We really want to try and find that best solution for a customer. So we employ a number of techniques to do that. First thing we look at is trying to understand what the workload is. I can do a design based upon any number of factors, but we like to do it on the customer's workload. So we use our HPC and AI Innovation Lab, does benchmarks for popular applications, kind of as new processors come out, and we try to find that individual sweet spot for an application amongst all the new different processors and server combinations that we could build. And then we try and apply that data or do new benchmarks for customers' data on tests that they find representative of their workload. And then we can figure out exactly how many jobs per day or whatever metric that makes sense from that benchmarking exercise, how many servers they would need to do so many jobs in a week, any number of ways to try and to optimize for the compute experience. Many customers have different measurements. So some may look at it as a rack space issue, that might be their most critical resource. Others may look at power and cooling. Some look at cost. Some look at, as Guy was just talking about with cloud options, some look at the cost of operating, and they want to look at an operational cost aspect. So there's many different ways to evaluate what is a Goldilocks. So what do, right? We try and collect as much data as possible from the customer up front through our consultation exercises to understand what limits are out there. Oftentimes, I need to know the physical stakes in the ground. So there are 10 stakes in the ground, for example. If a data center is limited to so many racks or so much power or so much heat, I have to compute that into the designs that we're building as a kind of a firm boundary. Once I get all the firm known limitations or known design points together, then we can start looking at, okay, what are the soft spots? Can we go and look at processors per or cores per server or cores per socket and look at the cost of those options? Can we tweak the power and cooling system configuration to get more of cost-effective cooling? We often look at deployment options. Dell, historically, for our large systems, we do an off-site deployment. Well, that has extra trade-off costs involved. Maybe it's a little quicker for the customer to get it up and running, but they may not have the storage space to host the equipment as it's being shipped in. So there's a number of aspects in that area. And then as Guy talked about, there's the whole options of explore hosting and cloud option opportunities today. So those can equally be analyzed in these and kind of this homework we do to kind of fit that. And I guess to show the complexity of it or the scale of it, my kids, when they were young, we'd love to play a game called Topple. So you have this tray sitting on a point, a stand, and you have to put these little pieces on top. And you have to make sure that the thing still balances, and whoever sends it out of balance loses the game. Well, that's kind of like business today. Our goal, our job is to build a balanced system for a customer that doesn't topple, that doesn't fall down because one of these aspects I've noted around here are not covered or not adequately addressed. And we may make some trade-offs to get one of these factors more in balance with the rest of the system and keep that plate, that tray there in a suspended state and not allow it to fall over. So it's an exercise. It's fun for most of us to do this. We enjoy engaging with our customers to look at these. And then I just want to summarize with the different resources that Dell has available to help in this. First is our HPC and AI Innovation Lab. We've talked about it before. Ashley zoomed over there earlier. We have engineers, data domain specific engineers and analysts that work on these benchmarks for us and understand the applications and give us that base information to build these analyses over or from. And then technical architects or engineers like myself, we're the kind of the HPC specialist working on the different applications and the deployment or HPC designs, and then the deployment services team we engage to make sure we can deploy what we're building and it will fit within the data center capabilities. Our Dell Technologies has one of the widest technology portfolios in the industry between all the compute, storage, networking, client, security products, hosting products, the financial services that Ashley was just talking about, the Apex model. All of this plus all of our partner companies that we work with, we feel give our customers a great opportunity to succeed with a deployment with HPC, with Dell, and trying to find something that fits in that Goldilocks zone. That's all I had for you today, Tony. Just a little quick recap. Hope that's good.
No, that's pretty good, David. So when customers want to find Goldilocks, who do they call?
We call Dell. Call your Dell sales account team.
Yeah, okay.
And then they'll reach out to the HPC team.
Great. That was a great presentation. Ashley, any last comments here?
You know, Tony, as we hear all of our experts, Guy, Elliott, and David have brought so much value just in a few minutes today. I can only imagine what happens in customer engagements that when time really gets invested there, And, another thing that I've seen really stand out for Dell's customers is the ability to work pre-deployment with strategists in addition to engineers. So in addition to the configuration itself, overcoming business challenges tied to high performance computing, it's also something that Dell supports, which we don't see all over the market. So just wanted to throw that in there, as I think it's a good value add for certain customers that need and rely on that expertise to help them get going and optimize their spend around high performance computing.
So that's an interesting point, Ashley. So that means that when a customer is trying to evaluate the risk in going for HPC, we have people that can help with the strategy on getting to the point where they say, HPC is probably going to work out for me. Let's dig in deeper and maybe find Goldilocks.
It's all about mitigating risk to get the highest speed, right? So we got to
balance
speed, but we also want to mitigate risk and preserve investments, and also the folks making those investments, right? We all know that you want to make sound decisions for the organization that's given you the funding, and so we really want to make sure that those sound decisions are supported by a good partner like Dell to make sure that risk is mitigated not just at the onset, but throughout that relationship with the OEM. All
right. Well, listen, thanks. Thank you very much. And I guess if you're searching for Goldilocks, you can call Dell to get a solution and help you find Goldilocks. So I want to thank everyone here today for being on the HPC Now podcast, which is, by the way, sponsored by Dell. And wanted to say, everybody be safe, and we'll talk again soon. Thank you very much.
Thanks, Tony.
Be well, guys.
Thanks, Ashley.
Thanks so much. Thank
Bye.
you.
Thank you.
Bye-bye.
Thank you.
Bye-bye.